In this video, I am going to do problems 71, 77, and 79 from Chapter 2. All of these problems have to do with atomic mass. Question 71 says, gallium has two naturally occurring isotopes with the following masses and natural abundances. Sketch the mass spectrum of gallium. So, whenever we have a mass spectrum, our highest abundance is going to be equal to 100%. So I've written 60.108 is equaling 100%. So what percentage does 39.892 represent? So we can do a simple proportion. If 60.108 is representing 100%, then the same ratio has to apply to 39.892 over x. So when we solve this, hopefully you get that x equals 66.4%. So now we need to draw our mass spec. So whenever we have a mass spec, the y-intercept is the y-axis represents intensity, and again, our most abundant isotope is going to be at 100%. And the x-axis is going to be the mass in atomic mass units, or AMU. So all we're doing is drawing this out. So when our mass is about 69 AMU, our abundance is 100%. It has the highest intensity. And when our mass was 71 AMU, it should be about 66%, so right about there. It doesn't have to be perfect, but you can obviously see that we have a lot more of gallium-69 than we do of gallium-71. Number 77 says bromine has two naturally occurring isotopes and has an atomic mass of 79.904 AMU. The mass of bromine 81 is 80.9163 AMU, and its natural abundance is 49.31%. Calculate the mass and natural abundance of bromine 79. Okay, so we're looking for two different things. Our formula for the average atomic mass is the mass of the first isotope times the natural abundance of the first isotope, plus the mass of the second isotope times the percent abundance of the second isotope, plus the mass of a third isotope if we have one, times the percent abundance of the third, and if we have a fourth isotope, then we do the same thing. We can keep going until all of our isotopes are taken care of. And hopefully you know that the total percentage of our atoms needs to be 100%. So if we're given 49.31% is bromine 81, then bromine 79 is going to be the rest of that. So we are going to have so 50.69% is going to be our bromine 79. So now we're going to plug in our values into our average atomic mass equation right here. So our average atomic mass was given, and the mass of our first isotope, let's call that bromine 81, is given, and its percent abundance was also given. The mass of our second isotope, bromine 79, that's our question mark. So that's going to be our x, and its percentage we just solved for. So now we have that. And we don't have a third or fourth or fifth isotope. We only have two. So when we plug it in, we get the equation at the bottom. And I want you to notice that since this is a percentage, we need to move the decimal place over 2 spots when converting it into a decimal. So that's why I have 0.4931 and 0.5069. So all we're doing is solving for x. And hopefully when you solve for x, you get 8.919 AMU. And remember, it's AMU because it is the mass. We are calculating the mass of bromine 79, which is very close to 79, so that's a good sign. Okay, so question 79 says to use the mass spec to determine the atomic mass of europium. So the first thing we're going to do is estimate what this mass spec says. Those values are about 100% and 90%. So those values represent the mass abundance of our specific isotopes. Okay, so if we have a total of 100 plus 90, because those are the values of the isotopes, that's the percent abundances from the mass spec, 100 out of that was europium-153, which means that about 52.6% of all of the europium atoms will have a mass of 153. Conversely, when we look at europium-151, about 47.4% of europium atoms will have that mass. So we can say that about half of our atoms have a mass of 153, and about half of our atoms have a mass of 151. So we could very reasonably assume that the average atomic mass is going to be about 152 AMU. So it's going to be 152.05. There's a tiny bit more of the 153 isotope, but this is a good answer based on these.